How does a random variable work in probability? Imagine flipping a coin or rolling a die. Each time the outcome is uncertain, but we can still assign numbers to these outcomes. That's where a random variable comes into play. It's a way to turn unpredictable results into numbers we can analyze. Think of it as a bridge between chance and math. When you perform a random experiment, like drawing a card or measuring the temperature, the set of all possible results is called the sample space. The random variable takes each of these outcomes and assigns a specific number to it. For example, if you roll a 6-sided die, the random variable might be the number shown on the die, which can be 1, 2, 3, 4, 5, or 6. This process makes it easier to study the experiment because now we're working with numbers instead of just outcomes. There are two main types of random variables. The first is called a discrete random variable. It can only take certain specific values, like counting the number of heads in 10 coin flips. That number can only be 0, 1, 2, and so on, up to 10. The second type is called a continuous random variable. It can take any value within a range, like measuring the height of a person or the time it takes for a light bulb to burn out. These variables are useful because they help us understand how likely different results are. For discrete variables, we use a probability mass function, which tells us the chance that the variable equals a specific number. For continuous variables, we use a probability density function, which shows how likely the variable is to fall within a certain range. Once a random variable is defined, it has a probability distribution. This is a way to assign probabilities to each possible value. For example, if you roll a die, the probability that the random variable equals 1 is 1/6, since each number from 1 to 6 has an equal chance. The value that the random variable takes after the experiment is called its realization. Before you roll the die, the outcome is unknown and considered random. After the roll, the number you see is the realization. Random variables are essential because they let us summarize complex, unpredictable events with simple numbers. We can then analyze these numbers using tools like the average or expected value, which tells us what we can expect on average. Variance measures how spread out the results are around the average. These tools help us make sense of uncertainty in everyday life. Numbers have always played a role in how societies understand chance and luck. The idea of a random variable formalizes this by assigning numbers to random events, making it easier to study and predict outcomes. Whether it's predicting weather, gambling, or economic trends, understanding how a random variable works helps us make better decisions. In essence, a random variable works in probability by turning the unpredictable into the quantifiable. It allows us to analyze the likelihood of different results and understand the patterns behind randomness. This makes it a powerful tool for exploring the role of numbers in society and everyday life.